Hello and welcome to our next section on our review in factoring. We're going to be taking a look at the work from your textbook in section 6.2. And this particular section covers factoring trinomials. Now, when we talk about factoring trinomials, we talk about factoring trinomials in a particular form. And specifically the form we're going to look at is the form of x squared plus bx plus c. Now, typically, when we talk about writing trinomials that we want to factor, we usually speak about those trinomials containing an a coefficient, written in the form of ax squared plus bx plus c. But if you refer to your textbook, the reason they leave the a out of this is because for this particular section, they are going to let the value of a be equal to 1. And since the value of a would be equal to 1, putting a there would not be necessary. So when we factor trinomials of the form of x squared plus bx plus c, the factoring or the procedure for factoring these is a lot simpler than factoring it when a is not equal to 1. So we're going to look at how we can factor these trinomials. And I'm going to show you a very simple technique that will help you do this. So we're going to jump in by taking a look at some basic trinomials and seeing how these get factored. So let's go to number 12 from the textbook. And this is going to be written as y squared plus 12y plus 27. So we're going to start with some very simple problem first, particularly where both the values of b and c are positive. Namely, in this problem, we're going to go ahead and identify the values of a, b, and c first. Now, you don't have to do this work if you're already comfortable with it, but for those students who may be seeing this for the first time or have not seen this for a while, this should help. Clearly, the value in front of here is a 1, or not clearly, but you may imagine it's so, if that helps. The value of b in front of the, well, not x term, but y term in this case, the value of b is going to be equal to 12. And then the value of c, or the constant term at the end, is going to be 27. So when we factor trinomials where the a coefficient is equal to 1, and we don't have a coefficient in front of the x squared or the squared variable term, we can set up the factoring quite easily in this way. Well, the only way we can get y squared is by multiplying y times y. So now what we have to do is figure out what goes in these other parts. Well, that's going to be the job of what I call the x box, which I'm going to put over here. Also, what I'm going to put in the x box is a multiplication sign here, represented by a dot, and an addition sign here. So what we're going to do is we're going to take the value of a times c, and we're going to put that value into here. We are going to take the value of b at the bottom. Yes, think b, think bottom, and we're going to put that here. So when we go to the values either from the trinomial or from the coefficients of the trinomial that we've collected from here, we're going to put this over here. So here a is 1, so that's going to be 1 times c, which is 27. So we see that a times c is going to be equal to 27. We can also see that the value of b is equal to 12. So what we're doing is we're organizing our numbers in a way that may be more easy for students to play with these values a bit. So what we're really looking at is we're looking at a pair of numbers that we want here. And we are looking for two numbers whose product is going to be 27 and whose sum is going to be 12. For example, if we have 1 times 27, 1 times 27 is 27. However, 1 plus 27 will give us 28, so that doesn't work. So we have to come up with two numbers and their correct signs that work for both. So let's try plus 9 and plus 3. So 9 times 3 is equal to 27. 9 plus 3 is equal to 12. So from here we have the correct values that we can now take and put into factoring these trinomials. So we're going to go ahead and put the plus 9 here and the plus 3 here. And now we have found the two binomial factors for the trinomial y squared plus 12y plus 27. So we have successfully factored this trinomial. Factoring trinomials are easiest, typically, when we have positive values for a, b, and c. Because all we do are find two numbers that multiply to the product and two numbers that add to this sum. It can get tricky when we have negatives, so let's just go ahead and practice one more question before we go on to some more potentially challenging problems. Let's take a look now at 14. Z squared plus 8z plus 7. Now, just looking at this, I realized that in the book it's slightly different, but I went ahead and I just changed it for the purpose of the problem that we have here. So, first thing we want to do is identify the coefficients of the values of a, b, and c. Obviously, as we mentioned before, a coefficient is the coefficient or the number in front of the z squared term or the variable squared term, which is going to be 1. In front of the variable term, we have b equal to 8. In front, or the constant term at the end, c, that's equal to 7. So we know because we have a equal to 1, I can write z squared here as z times z. So now we're looking for two numbers that multiply to 7 but that add to 8. So we're going to go ahead and organize our information over here, putting multiplication sign here, putting an addition sign here. A times c here and b here. Now, you don't always have to put these symbols in here. I put these in here for the first few times so that you get comfortable with the procedure and where the numbers go and where they're gotten from. So, because a is equal to 1, for this part we can look only at the value of c because 1 times 7 is going to be 7. However, when we look at problems later where a is not equal to 1, the a times c is going to be very important. So that is why I'm teaching it from this point now. So we have 1 times 7 being equal to 7, and then b being equal to 8. So right now, we're looking for a pair of numbers that are going to go here that multiply to 7 and that add to 8. Well, there's only one way to get a product of 7 and a sum of 8. That's with plus 1 and plus 7. So I'm going to go ahead and put plus 1 here and plus 7 here. In case you're wondering, some may ask, does it matter if I put the plus 7 here and the plus 1 here? It does not. So if I were to make this z plus 7 times z plus 1, they're both the same pair of binomial factors, therefore the answer would still be correct. So these are the two binomial factors for z squared plus 8z plus 7. We're going to go ahead and take a look at one more problem with using two positive values for b and c. So this is just an example that I'm going to pull out of the air, and I'm going to call this now x squared plus 13x plus 40. So I wanted to pick an example that might be just a little more challenging for some people out there, but not terribly difficult. So what we're going to do first is let's identify the values of a, b, and c that go with us. Well, we already know a is going to be equal to 1, b is going to equal 13, and c is going to equal 40. So now I'm going to go over here. I'm going to make up my X box. I want to find two values. Remember, this is a times c. Two values that multiply to 40 and that add to 13. So sometimes when you're trying to think of what these values are, if you don't know all of your factors of 40, you may have to list these on the side as follows. So we're finding all the ways to generate multiples of 40. We're going to do that below. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So some of you may take a little more time to think about that, but this is the work that's needed. So all of these pairs of numbers are factors of 40. All of these numbers multiply to 40. So any one of these can go here, except we have to come up with the correct pair of numbers that's going to add to 13. And among these, if we were to add these now, we see that only one pair adds to 13, and that's going to be 5 times 8. So I'm going to write this as 5, and I'm going to write this as 8, because only 5 times 8 will give me 40, and 5 plus 8 will give me 13. So I'm going to start by putting x here. Afterwards, I'm going to go ahead and I'm going to find these two numbers, plus 5 and plus 8, put those in, and now I have my pair of binomial factors that I factored from the trinomial. If you want to check to see that these are correct, one way to perform a check is to multiply the binomials together, just to be sure that you've done this correctly. So one way you'll see that I will FOIL, as I've done in an earlier video, is I FOIL in the following way. I take x times x, I skip maybe a line or two, and I write this as x squared. I take 5 times 8, and that's going to give me 40. So far, so good. I'm going to take 5 times x here and get 5x. X times 8 here to get 8x. And then I add these two numbers together, which is going to give me plus 13x. 40 is positive, so I'm going to put a plus there. I get the result that I have above here, so I now know that I've done these correctly. So this is the first part of this, and again, what makes these first three problems unique is that A, B, and C are all positive. Well, let's say we have an example now where maybe that's not always the case. So let's take a look at such a problem in question number 13. We have here a squared minus 7a plus 12. Now, a is the variable here being squared. So do not confuse the values of a, b, and c that we use in these quadratic expressions. These are trinomials also, but we can refer to them as quadratic expressions. We'll discuss that in a later chapter. Do not confuse the value of a here with the variable that is used in the trinomial. When we talk about a, b, and c, we're still talking about the coefficients or the numbers that are in the trinomial. So here, there's no coefficient, so we know this is equal to 1. Here, b is a negative value now. In fact, b is negative 7. So this is a bit of a change from what we were doing before. The c here is still positive, and that's going to be 12. So how is the fact that we have a negative value of b going to change our work? Let's go ahead and go to the x box and put our information in. We're still going to have a times c at the top, and we're still going to have b at the bottom like we did before, with a multiplication sign here and a plus sign here, because whether we work with positive or negative numbers, we still add them. So we need two numbers, a times c, that multiply to be a positive 12, but now we need their sum to be negative 7. So by rules of multiplication, the only way we can get a positive product and a negative sum is to multiply two numbers together that are both going to be negative. So a negative times a negative is going to be positive, and then when we add two negatives together, we should come up with a negative number. So we need two numbers that multiply to a positive 12, but that add to a negative 7. Since we're adding two negatives together, it's very similar to adding two positives, only the numbers are negative. So if we look at all the numbers that multiply to 12 that are negative, we can say, for example, negative 1 times negative 12. Negative 2 times negative 6. And then negative 3 times negative 4. All these combinations of numbers multiply to 12. However, if we were to add these numbers together now, negative 1 plus negative 12, this will add to negative 13. Negative 2 plus negative 6 adds to negative 8. And only negative 3 plus negative 4 will add to negative 7. So since these numbers will both multiply to positive 12 and add to negative 7, we are going to put negative 3 and negative 4 for our numbers here. So what that's going to mean is when we identify the first part of each binomial to be the square root of a squared as a times a, we're going to take the two values we obtain here, namely minus 3 and minus 4, and use that to make up the second part of our binomial factors. Therefore, we have the pair of factors a minus 3 times a minus 4, representing the factors of a squared minus 7a plus 12. Let's take a look at a couple more examples before we go into the next type of factoring. So the next problem we're going to take a look at is going to be stay put. And this is just an example I'm going to utilize for this one. This is going to be x squared minus 9x plus 20. Okay, so let me identify my values of a, b, and c. The value of a, of course, is equal to 1. B is negative 9. And c is positive 20. So when I make up my x box again, and by the way, I heard a few comments about students asking me perhaps to write the first part of the problem separately before I begin to incorporate work around it. Well, what I encourage you to do, since you have the ability to pause this video, if that's a step that you think may help you along the way, go ahead and stop the video and rewrite the problem a second time so you can retain the original problem first and then save any work around it that you, or copy any work around it that you want. I'm not going to do that for the video because you have the capability of stopping it to adapt the notes whatever best suits your individual needs. So, going forward, we need two numbers that multiply to 20, positive 20, but that add to a negative 9. So, if we look at all the numbers that are going to multiply to 20, again, recognizing that the only way we can get a positive product in a negative sum is to multiply two numbers that are negative. So this could be negative 1 times negative 20, negative 2 times negative 10, negative 4 times negative 5, and I think that's it. But if we would add these together, this would be negative 21, this is negative 12, this is negative 9. Only negative 4 and negative 5 give us the sum of negative 9. So we now have the pair of numbers that are going to go into the factors. So the square root of x squared is x, and then we have minus 4 and minus 5. So now we have our pair of binomial factors in this question, and we're going to take a look at one more problem to give us some additional practice to help us better refine this skill. Let's go with p squared minus 13p plus 30. So again, let's take a look at the values of a, b, and c. A being equal to 1, b being equal to negative 13, and c being equal to 30. Now, for those watching this video who think maybe this is a little boring, or I already got this, well, this is important to reinforce these basic skills because the next type of factor we're going to look at in the next video is going to be a little trickier, and some of you may have more difficulty with it. So being proficient here is going to be very important. So here, we're looking for two numbers that multiply to 30, 1 times 30, and that add to negative 13. Well, the numbers that multiply to 30 are negative 1 times negative 30. Again, these are going to be two numbers that have to both be negative. Negative 2 times negative 15, negative 3 times negative 10, and negative 5 times negative 6. So we need two numbers who have a product of 30, which all these do, but who have a sum of negative 13. Only negative 3 times negative 10 has this. So when we write our binomial factors, we're going to write these now as p minus 3 and p minus 10. And now we have the pair of binomial factors for this. All the examples that we looked at in this video have all contained a equal to 1 and a positive c value. In the next video, we're going to consider when the value of c is negative, which means that the product is going to be negative, and we're going to see how it's going to impact the work we do when factoring trinomials.